Okay, good morning, good afternoon, wherever you are. Today we're going to be doing the first lesson in the next unit, and this is called Inductive Reasoning and Conjectures. All right. So, what is inductive reasoning? All right, we're going to do. Most people already know a lot about inductive reasoning; they just don't know it by this word. Okay, and basically, it's reasoning, right, or making conclusions that use numbers, a number of patterns in examples to arrive at a conclusion. So, for example, that sounds complicated, right? If I said two, right? Two, four, you don't have to write this. Six, what's next? You would say, oh, eight. Why? Well, it's going up by twos. Is it? Right? You don't really know, right? Maybe the next number, maybe the next thing is star, but it's based on patterns, right? Making conclusions based on patterns, right? Everybody starts off that way. We look for patterns in things and then we try to describe them. Okay? So reasoning that uses a patterns to arrive at conclusions. A conjecture is the concluding statement based on the inductive reasoning. All right, so what does that mean? When you see 2, 4, 6, 8, and I say, what's the conjecture? The conjecture is, oh, this problem's going up by twos, right? That's what a conjecture is. So big words for common sense ideas, all right? So basically, write a conjecture that describes each pattern using inductive reasoning, all right? So here we go. What do we see here? Well, the next movie starts at 9:45, right? Which is an hour and 15 minutes later, right? So this one's an hour and 15 minutes later. This one's starting an hour and 15 minutes later, right? This one's starting an hour and 15 minutes later, blah, blah, blah. So here we go. What's a conjecture, right? The conjecture is movies start 1 hour. Holy cow, my pen's just really getting bad. Sorry, guys. 1 hour and 15 minutes after the last movie, right? And there's lots of right answers here, okay? So that doesn't have to be the only answer it could be, all right? All right, next problem. There's lots of ways you could look at this next problem, but we're going to focus in on these numbers, 8, 10, 18, 28, and 40, right? So let's just look at some stuff. That's what? Plus 6, plus 8, oh, plus 10, right? So you would predict the next one would be plus 12, and it is, right? So now we have the pattern, but it's kind of hard to describe, right? And if you wanted to make a conjecture, there could be lots of right things. You could start off with some crazy quadratic equations for the pattern or whatever else, but we're just going to keep it simple, right? First, you add what? 6, then 2 more than the last each time. All right, that's it. All right, so let's look at example 3, right? We got this picture, right? So I would say 1 hole shaded. There's lots of right answers here, all right? And then I would say 3. I'm just going to play here so you can just see there's lots of things you could say, right? So what do we're cutting it up into 4 pieces, right? We cut it up into 4 pieces and we shade 3 of them, right? And then what do we do? Well, we took this piece, right? The pieces that weren't shaded before. You see these pieces, right? Here, here, and here. We took those pieces, we cut them up into 4 pieces, and we shaded 3/4 of them, right? So how do I describe that? That's going to be hard to describe, right? This is actually called Pinsky's triangle. And if you have one of my math team shirts from our team at the Flower Bluff, you'd see this picture on it, right? So I would say something like this. And there's lots of right answers, so don't worry about it. After the first, you break break up the shaded regions into 4 pieces and shade 3. Is that the best answer? No, but it's basically what's happening with this pattern, okay? All right, make a conjecture about each value or geometric relationship. List or draw some examples that support your conclusion. The sum of 2 odd numbers. Well, let's just do it. Let's just add some odd numbers. 1 plus 3 is 4. 3 plus 7 is 10. 7 plus 11 is 18. What do we notice? Right? The sum of 2 odd numbers is always an even. Done. Okay? That's it. That's all you're going to be doing there. All right, next section. The number of diagonals drawn from one vertex of a regular polygon. All right. So this one I would probably keep track of, right? Number of sides and then number of diagonals, right? So let's say it's a 3-sided. Let's do a 3-sided figure, right? 3-sided figure. How many diagonals can I draw from here, right? When it was 3-sided, I can't draw any diagonals because they're already made. What about when it's 4-sided? From this corner, right? I can make 1 diagonal. What about when it's 5-sided? Well, let's look at a 5-sided. Let's go from here. 1, 2. Can I predict a 6-sided? Well, it looks like, look, 3 is 0, 4 is 1. It looks like it's 3 less. So this one would look like it'd be 3. All right? So it looks like it's always 3 less than the number of sides. Yeah? So let's try a 6-sided real quick just to verify to make sure we're right. All right? 1, 2, 3. We're right. So the number of diagonals is 3 less than the number of sides. All right. Next one. The product of an odd and an even number. All right, well, let's try it. 1 times 2, right, is 2. Product of an odd, 3 and 10, 30. 5 and 11, 5 and 12, 60. Oh, okay, well, an odd number times an even number always makes an even number, right? The product of an odd and an even integer is always an even number. I wish I had more time right now. This one's kind of interesting to talk about. There's some interesting conversations we could have, but I don't want to make this video too long. So, next one. If a plus b equals 0, okay, how is this possible? Well, let's try to find some problems at work. 3 plus what makes 0? Oh, negative 3. 2 plus what? Oh, negative 2. Is there any other ways to do that, right? I mean, I could do something like negative 4 plus positive 4, right, would make 0, but are there any other ways to do that? And the answer is I can't think of any, right? So if a plus b equals 0, then a and b are opposites. Right? So you're going to do problems like this tonight. There's a lot of right answers. Make sure you're justifying it. Make sure you're showing examples. But it's a really easy assignment. I don't think you're really going to have problems with it at all. So good luck with it. If you need help, let me know. All right. Take care. Bye.